This is variation. We're looking at direct variation, inverse variation, joint variation, partial variation. And this is powered by Brain Hub Academy by Kenneth Michael. Always share with your friends. All right, this is the topic variation. Now, what is variation? Variation is used to describe the relationship which exists between two quantities. So it is used to, explain relationship that exists between two quantities. Types of variation, which we'll be looking at, we have direct variation. This is a type of variation in which the relationship that exists between two variables is such that if one variable increase, the second one increase also, and vice versa. So symbolically, x is directly proportional to y. Read as x varies directly as y. X is going to be equals to k y. The k is a constant. Where k is constant, in order to remove this sign of proportionality, we have to introduce a constant k. So note, this symbol is used to represent proportionality. All right, so direct variation in practical reality, what it means is that when a quantity increase, if the other quantity in relation with it also increase, then it's a direct variation. Or in a reverse case, when a quantity decrease and it leads to the decrease of the quantity in relation to it, then it's also a direct variation. So example 1, look at this. Given that y varies directly as x, when s is equals to 3, y is equals to 4. Calculate y when s is equals to 7.5 and x when y is 16.5. Now, solution, we have y, according to the question, y varies directly as s. This is a mathematical representation of it. Y varies directly as s. Y is equals to kx. Why do we use the k? We use the k in order to be able to remove the constant, the sign of the proportionality. So we are introducing k to it, where k is a constant of variation. But from the question, y was given initially, y and x is given to be 3, y is given to be 6. So look at it, but y is equals to 6 when x is equals to 3. So therefore, by the time you substitute this value into this relation, into this formula, you discover that in place of y, we have put 6. Then in place of x, we put 3. Because 3 times k will be 3k. So make k the subject of formula k. Therefore, k will be equals to divide both sides by the coefficient of k. The coefficient of k here is 3. So it will be k equals to 6 over 3, which is 2. So the value of the constant k is 2. Now, there are questions that follow. They say we should calculate y when x is 7.5. So we want to find the value of y now when s is 7.5. So to find y when s is equal to 7.5, already our k is equals to 2, which we have calculated already. So therefore, the relation still stands. Y is equals to kx. So therefore, y is equals to ks. K is 2, that is 2 here, times x is given to be 7.5 this time around, which is what we bring here. 2 times 7.5 is 15. Also, they say we should also find x when y equals 16.5. So therefore, also to find s when y equals 16.5, k is equals to 2 already, which we have established. So this is a relation. Y is equals to kx. So 16.5 is equals to 2x. All right, so therefore divide both sides by the coefficient of x. The coefficient of x is 2. So therefore 2x is what we have here over 2. 16.5 is for y. It's what we have here over 2. 2 will cancel 2. You are left with only x, which is therefore x is equals to 16.5 divided by 2 is 8.25. So that is the value of x. Example 2. If the resistance R ohms to the motion of a moving vehicle varies directly as the square of the speed v. If it varies directly as the square of the speed v and measure in kilometer per hour, write down the relationship between R and V. Okay, so given that R is equals to 600 ohms when V is equals to 20 kilometer per hour, find the speed when the resistance is 337.5 ohms, when find the resistance when the speed is 32 kilometer per hour. Now to find this, I say the resistance is directly from the question. If the resistance R, or in ohms, measure in ohms to a motion of a moving vehicle varies directly as the square of the speed v. Square of the so R is directly proportional to v square because it's square of the speed. Removing the sign of the proportionality, we have that R is going to be equals to k v square. Our k is our constant of variation. So from the question, they give us values to be able to find our k. To get your k, discover that your R is given to be 600, your V is given to be 20. So therefore, when R is 600 and V is 20, k can be gotten thus. R from the formula is equals to k v square. R is 600 equals to k is not given. V is given to be 20, which is 20 square because there's square here. Is what we effect here. Therefore, 600 is equals to 20 square. That is 20 times 20 is 400. 400 times k is 400k. We are looking for k. So therefore, divide both sides by the coefficient of k. You discover that your k is equals to 600 all over 400, which is going to be equals to 1.5. All right. So now that we have it, now the first question they say we should find. We should they ask us to write down the relationship between R and V. So the relationship between R and V is going to be equals to R equals to 1.5. This 1.5 now represents the value of K V square. Remember, initially it is R equals to K V square. So, but we have found the value of K, which is a constant. So we impute it into the formula to give us the relationship between R and V. So therefore, R is equals to 1.5 V square. So now they ask us to find the A part. We should find the speed when the resistance is 337.5 ohms. Okay, now if you are looking for the speed when the resistance is given to be 337.5, it will be already our relationship R is established already. R is equals to 1.5 V square. So therefore, in place of R, we write 337.5, which is equals to 1.5 V square. So here, what we are doing is that we are going to divide both sides by the coefficient of V square, which is 1.5. So therefore, V square is going to be 337.5 divided by 1.5. This is what we have here. So therefore, V square is going to be equals to this 337.5 divided by 1.5 will give us 225. But we are looking for V, not V square. So therefore, we are going to take the square root. Take the square root of both sides. If we take the square root of both sides, you discover that the square root here will cancel, the square root here will cancel this square, and then it will form a square root at the right hand side. So the left hand side will be V, ordinary V equals to square root of 225. And square root of 225 is going to be 15. Remember, speed is measured in this question as kilometer per hour. So the next question, the B part, they ask us to find resistance when the speed is 32 km per hour. We are looking for resistance now. We are using the same relation. R is equals to 1.5 V squared. That is what we are still using. Alright, so when V is equals to 32, R will be equals to 1.5 V squared. R will be equals to 1.5 times the V is given to be 32. So it's going to be 32 squared, which is equal to 1.5 times 32 squared. That is 32 times 32 is 1024. Alright, and then 1.5 times 1024 is going to give us 1536. So therefore our R is 1536 ohms.